I'm CK. Tonight we're gonna build a small component tester, transistor, and I think some other components. The only challenge is this is what I got. The parts and the board, no manual, no instructions, don't know how it's going to work, don't know, I mean, the board is laid out pretty well. All the components are clearly marked, except it actually doesn't tell me how much the power is supposed to be. I can see where the power goes in, but there's no voltage listed, so I'm going to have to experiment a little bit with that. I figure starting out with 5 volts and going up to 12 is always a good exercise. But we'll get to all that later as we dive into it. The other thing I'm going to be trying tonight is I've added an overhead camera, and I'm going to see if we can get some side view and overhead. We'll see how that works out. Hope you enjoy it. Off camera, I inventoried all the parts and organized them a little bit, and it answered one of the questions that I had in the intro, which was the power that's going to go into this. And if I had looked more closely at the board, right here is plus minus 9 volts. Of course, you don't actually have to look at the board. If you get a parts list that has this, it's kind of a dead giveaway that it's 9 volt now, isn't it? Sometimes you're smart, sometimes you're not. So since this board doesn't have any instructions, we're just going to go ahead and slap components on based on the markings on the board. The board is very clearly marked for everything that's going to be in there, so I'm not too worried about that. There are 3 surface mount components. This, I looked up the part code. This is a Zener diode. This, I believe, is a small capacitor, but I'm not sure. And this little 6-pin guy, I can't figure out what that is. Traces are going to the resistor into the test fixture from 2 points, and then by this diode to some output, PWM, pulse width modified modulated output, and then all the way over to the actual IC that controls this thing. So I'm not sure what it is. I'm not going to take a guess. And if I'm going to take one further look, no, I looked really hard trying to read the parts marking on it, but I couldn't. The only other thing, I don't know what it is. I don't know what these pads are. They're marked 1, 2, 3, and I don't know what they're for. So we'll see. If I end up with extra parts, we'll see where they go. So I'm going to start, as one does, with putting all the resistors on the board. So we've got 1, 2, 3, 4, 5, 6 10K resistors. So I'll put them all on. One thing about the board is a nice board. The solder pads, while they're a little small, are clean. Solder's going to adhere to them well, and the plating goes all the way through. So you're getting a bad solder joint is going to be really hard to do. One thing that's nice is all the resistors are 1% tolerance, so high quality resistors. A minor thing, but I like to notice things like that because it tells you how serious the kit manufacturer is about the kits, quite frankly. Whether they're just cranking them out or whether they want people to actually benefit from them and get not just a good product but confidence. Because a lot of the kits I'm getting are aimed at, okay, now we'll do the 680s, 680 ohms, are aimed at the market for people, not children or youngsters, but the market for folks to get experience assembling and possibly even learning circuit design at home so they can go get a factory job. And as such, they don't want to make junk because they want people to get a job at a cell phone manufacturer or a TV manufacturer to tell their friends, yep, I put together KK Moon or some other kit, maker's kits, and that taught me all the skills I needed to get a good paying job. And I always look at that motive as a more powerful motive than many others. Pedagogy is a fine motive, but it's a limited market too. Making money, yeah. Getting people good jobs, yeah. That's going to get people buying your products. So I'm going to go ahead and solder these. I thought so. The TL431, which goes here, is a voltage regulator. So I'm going to plug that in first if I can find it. Oops. Next, we've got an 8 megahertz crystal. Okay, now we've got an LCD display mounted on a board with a driver and coupler and one resistor, but we've got to put the socket on the board and the connector on the LCD board. So I'm going to move this back for a second, bring in the pan of ice. Easy enough. Now we'll put the receiver And always we'll try and get it perpendicular. And we'll see if we can get it perpendicular on the first shot. Did we make it? Nah, close enough. Just a couple of more components left. First, the test jack. These screws don't look flush. Not the way I would like to do it. Okay. So these traces are interesting. These 3 traces go to these flat connected pads. So possibly alternately you just set. You can't use the pointer to solder with though. That's unfortunate. So if you don't want to clamp a transistor in, maybe you can just press the leads down against those pads and get a reading. Again, I'm not quite sure how this thing works because there's no documentation with it, but we'll figure it out. Okay, just a couple more. Let's make sure that works. Yep. A couple of more little things. Actually, just 2 more components to solder on. First is this potentiometer, which I don't know what the heck this is for. Because it's not small, and it's not like a trimmer. It's a full-on... Ooh, it's even notchy. Wait, it's continuous. Huh. It may be a rotary switch, not a trimmer. Or a potentiometer. Huh. Because it is. It's infinite. Or continuous. No stops. One more thing to put the battery leads in. We'll just do that on the table. And then there's a positive center pin, power connector if you want to use a 9-volt power wall wart power supply, which I might. So that's all the components on the board except for plugging in the IC. Let me do that before I forget. I don't want to power up without the IC installed. I've done that, and things, interestingly enough, don't actually work when you do that. Notch, notch. Now this is an Atmel ATM EGA 328 Papa. We'll look that up here in a second. This is my scrap and rework collection, which is probably kind of good to use for. Now what we have here, as you can see, I think you can see it on the overhead. I hope you can see it over here because I don't know which camera I'm going to use. There are markings on the board. One covers these 3 pins. 2 is this center pin, and then the number 3 covers these 3 pins. So we're going to have to assume that one would take a transistor and put it in those three slots. Yeah. Lock the lever and test. Or alternately, as I mentioned, I don't have enough transistors in here. Alternately, as I've mentioned, these pads, that's 1, 2, 3, so you could theoretically splay out the leads like that in a tripod way and just touch them to those silver pads, but we'll see. But first off, I'm going to take this transistor back out and I'm going to grab the battery, and there's no on-off switch here, so it should come live as soon as I plug this in. And ain't got nothing. LED's not lit. Board's not lit. Maybe turning this rotary switch. Now is the time. Of course, nothing's happening. Sure, we got the volts. Huh. Nope, we got 9 volts there. And 9 volts to there. power's coming in. Let me see if there's anything in this voltage regulator that's interesting. I'm not seeing anything at the voltage regulator. Let's see if I can... I'm going to disconnect the battery. And see what's up. Display back out. And this chip may not be seated all the way. Not just going in the right direction, which is always a concern. Okay, this one pin is acting up. There we go. Try it again. Nope. Got to put the display board in. Nope. Okay, I'm just going to start following power until it stops. You can't see from that from the overhead, you can see it from the ground, okay? Plenty of power there. Goes to that transistor. Doesn't go through because the transistor's up. Nope, I'm getting power on both the collector and the base. Making sure nothing's bridged. Voltage there. That voltage there. So I got voltage to the voltage to the IC. Yeah. Now, this trace off the display goes all the way down to this rotary. Maybe it's a contrast selector or something. I don't know. I'm gonna grab a 9-volt power supply and plug it into the wall and see if that's what the issue is. It doesn't have enough potential. Let's see. 12 volt. Got my handy dandy Belker switchable wall wart. Now we just have to find the right connector. Let it go in, okay. Take that up to the wall. Get this contraption out of there. Ta-da! Nothing happened. Well, I really don't know what's going on. Solder joints are all good. Everything looks fine to me, but no activity. Let me check this diode here. Which one is it? Nope, not getting anything there. Is there anything coming in here? We got 9 volts to this little rotary switch. And if I rotate it, voltage doesn't change. There's 1 volt there, and I switch to the other pin. Showing 1 volt, and then I rotate it. No. Well, I'll admit it, I'm stumped. I don't know what's going on. I've done a bunch more analysis of this to see what's going on. Did a bunch of circuit tracing, checked some components, the ones I can check. I'm not going to desolder capacitors to check them. There's no power getting to the video display. Power seems to stop short of in various places, and without a schematic or a user's guide, I really don't know where to look. Interestingly, the Amazon page, I bought this from Amazon, the Amazon page for this kit is no longer available, and when I go to KK Moon's site and click their link, it's no longer available there either. So perhaps they had too much trouble with this kit and decided to discontinue it. So not a successful build, but interesting nonetheless. Thanks for watching. Well, now, after I just said that, I did a little more poking and prodding, and I've gotten the LED to light, and the screen is lit up, even though it's not doing anything. And the poking and prodding I did was somewhat accidental. I was poking and prodding in a variety of things, and then rested the meter lead in my hand on the back and down around this area, and I bridged two of the contacts on this rotary switch, and the LED came on and the display came on, even though, as you can see, it's not displaying anything, but it is lit up. So that's progress, I guess. I'm going to take a transistor and put it in the jig and see if anything happens. Well, nothing's happening. The light and the screen are still on. I'm going to move this rotary switch, which again, I have no idea what it does. And it doesn't seem to be doing anything in particular. Maybe it's contrast. I don't know. Taking it both ways. And again, it's an infinite switch. So it's just sending pulses, which I assume are going to the microcontroller, and the microcontroller is counting pulses for some reason or other. But it's not doing anything now. I'm going to be bold and adventurous and take the power off. Now try and put it back in and see if it actually starts. Okay, again, putting the power back in. I'm not getting anything. I'm going to try and do what I did before and bridge some contacts. Because this is science. When you're bridging contacts, you're doing science. And there. I bridge those two. Oh, there it goes. Look at that. Look at that. Look at that. It came up and did something. So it seems to indicate that this is a NPN transistor. It's getting 3.3 milliamps. Seems fine. Now I'm going to move this rotary switch, see if it does anything. Oh, it's got settings. Transistor frequency, pulse width modulation thingy. Now the question is, how do I select it? Oh, it's got a push. Oh, look at that. I hadn't gotten to this point. So you can push the rotary switch and make various selections. Let me make sure you're getting all this. So it does appear to be working. Just checking the battery. The battery's okay, and then it went into test. And that's good. So that transistor worked fine. Let me pull the transistor out and see what it does. Okay, I'm going to press the button again. So maybe, because I didn't know this was a press, maybe this rotary switch is simply a toggle to turn it on and off. Which, since I didn't have any guide and I didn't know it was a push to test or push to turn on, I didn't know that worked. So put another transistor in, testing, and it says this one's good too. Okay, so there we go. It does actually work. Huh, what do you know about that? I'm going to do one more thing here because I figure it might be fun. I'm going to use the pads. No unknown or damaged part. In other words, with nothing installed, it says I can't test this. I'm going to put it on these little silver pads. Not calibrated. For calibration, clamp the 3 pins together and start with the key. Acknowledge self-test with something. Oop, and now I've turned it off. Oh, that is the on-off switch. Well, that sure does put my heart at ease. Oops, I've got the pins right. Okay, so it does work. And it does test transistors for me. Let's look at the 8-bit pulse modulation just to see what that does. Okay, I'm gonna turn off the cameras, reposition my oscilloscope, and we'll take a look at the pulse width. This is exciting. It does actually work. Now that I've finally got this figured out, I figured I'd give you a couple of more things, see what else it can do. Here's an inductor. So let me get the inductor in the right holes, slots, clamp it down, and there we go. 0.4 ohm, 0.14 megahenries, or microhenries, whatever, I never get henries right. And still showing the battery voltage, so we'll take that out. Let's try this. Comes out 2700 ohm resistor. Great. Let's see what else we got here. Let's try a capacitor. I don't know if it can do a capacitor. I haven't tried a capacitor yet. Let's see. Well, it's not doing the capacitor. I restarted it. Oh no, it did. It's a capacitor tester too. 8.2 nanofarads. Well, what do you know about that? This little device, much against my initial impression. Let's put a regular resistor in there. Sometimes it looks like you have to restart it. But it can obviously sense the difference. Sense the difference between an inductor, a capacitor, and a resistor. But not necessarily switch. I'm going to disconnect the battery, plug the battery back in, press. $197 ohm, close enough. Now this is all dandy. Now another thing I did see, which I'll look for here in a second if I can show you. No unknown or damaged part. That's good. But then it gave me a URL for actually how to use it. Of course, it's kind of funny to have a URL if you couldn't get at the URL to begin with. Alright, now we're going to plug, the thing is still on, so now we're going to plug into the PWM output and see if anything interesting happens. Oops. And there it is. there's the pulse width signal. Let me set this to roll. And there we've got a nice little pulse width pulse. So dandy. Okay, so it does apparently work. It was just user error because I didn't know to simply press on the rotary switch to turn it on. Now I know. So it does work, and it does correctly check transistors. So it's a handy little device. Still can't buy it anymore apparently, but at least it works. Very exciting conclusion. Thanks for watching.